Hello, today I will start the much awaited topic that is friction in laws of motion. तो आज हम लोग देखेंगे if friction is also included in addition to other forces, then how a numericals will be solved. ठीक है?
Okay, so finally we are starting the topic friction. Let us first see how this friction is originated. What is the cause of friction? As you must be knowing what is friction. Friction is resistance of surfaces in contact to avoid relative sliding among them. So let us first see its origin. When we see two objects are in contact, two surfaces are in contact, then even if it is a smooth surface as appeared to us, but still microscopically if we see that surface is not smooth, it has to be irregular microscopically. So if we draw this surface microscopically, you can see that only few points are there which are in actual contact. What we can see with our naked eye is that the whole surface is in contact. But if you see it microscopically, only few contact points will be there. So on these contact points, a large pressure is exerted, and due to this large pressure, chemical bonding is developed between the points. And if we want to slide one surface against the other, these bonds has to be broken, which is the cause of friction. So we have to apply the force to break these bonds. That is why we explain friction as it is the force that opposes relative sliding between the surfaces. It does not oppose the motion. No, this is not true. It opposes relative motion. So it opposes relative sliding between the surfaces. Even if sliding is not there and only tendency is there for relative sliding, then also it opposes its tendency. So friction is a force that opposes relative sliding between the surface or its tendency. Now you have seen what is the cause of friction, what is its origin, and what it does. Sometimes friction itself is responsible for motion of a body, and in some of the physical phenomena like walking on the road, and for a lot number of things while writing on the board, for a number of phenomena can be explained with the help of friction, and friction is helpful in performing these things. So friction is not unavoidable thing. It is very helpful. Sometimes of course it should be minimized if not completely avoided. Now we have seen, so after knowing the cause of friction, we will go in some detail about friction that will be useful to solve a mathematical example. First, some laws of friction are there. The first law is that friction force depends on normal reaction. So it depends on normal reaction. Actually, it is directly proportional to. It depends on normal reaction. It is directly proportional to normal reaction, we can say as well. The second law is that it is independent of area of contact. Just now I had told you that friction is caused due to the actual points in contact, and now I am saying that it is independent of area of contact. Of course it is independent, but it is independent of macroscopic area of contact, not the microscopic one. So what we see the area in contact, it is independent of that. Of course it depends on actual area in contact. So as far as normal reaction is same, it has nothing to do with area in contact. Friction force will remain the same. Now we can categorize friction in three different categories. One is static friction, other is kinetic, and third is rolling friction. As the name itself suggests, static friction is something that opposes tendency of relative sliding between the surfaces. So this one opposes tendency of relative sliding, not the actual sliding, only its tendency. So whenever there is tendency of relative sliding, then this force comes into action. Now what is tendency of relative sliding? See, let's say if an object is placed on the ground, a box is there on the ground, and if you want to push it with some force, let that box be very massive, then is it possible? Of course you are applying a force, but does it start moving at the moment you have applied the force? No. Because though you are applying the force, an external force is being applied on the body, but still it is not moving it means that there must be some opposite force. And what that opposite force has to be? It has to be static friction, because the box has not started moving yet, so that friction has to be static. The term itself suggests that it is not related to motion, just tendency of motion. Whenever you apply a force on something, it has the tendency to move, but then friction comes in contact from the contact surface and it avoids the movement till the external force is very large, so that it can overcome the maximum possible value for the static friction force. So the first thing that we can say about static friction is that it opposes tendency of relative sliding. The next thing is that it is self-adjustable friction. Now what is this self-adjustable? Again consider one example. Let one box is placed there on the ground and you are trying to move it. So you are applying a force. When you were not applying a force, it was simply kept on the floor. No friction was acting between the floor and the box. But when you started moving, at that moment, friction came into action. If you increase your force, friction also got increased. It will continue increasing till you keep increasing external force, and a moment will come when when the friction has reached its maximum limit. That is called the maximum limit of friction. So static friction is something that can adjust its value according to the need. It will start from 0 and will go up to the maximum possible value, which is called the limiting friction. So we can write its range as from 0 it will be having value. The static friction I am denoting by Fs. So it is greater than equal to 0 and less than equal to the maximum possible value of friction, which is called the limiting value of friction, and its value is equal to mu s times n. What is this mu s? This is called coefficient of static friction. As you can see here also in law of friction, I had written that it depends on n, and said also that friction is actually proportional to n. So if it is proportional to n, if we equate this, if we replace this with some proportionality constant, this proportionality constant is called coefficient of friction. So if it is for a static friction, it has to be coefficient of static friction, which I have written here as mu Sn. So static friction has its range from 0 to this limiting value. Now next come to kinetic friction. When the object actually starts moving on application of force, then whatever be the friction between the contact surface and the object, that is known as kinetic friction. So it opposes relative sliding, not only its tendency but the actual relative sliding. So it is associated with relative sliding between the surfaces in contact. Now this is not self-adjustable, its value is fixed and that value is equal to Fk. Now I am writing for kinetic friction, its value is fixed, which is equal to mu k times n. Again you can say this mu k is coefficient of kinetic friction. One more kind of friction is there, which is rolling friction, when the motion is of kind of rolling. And you must have experienced that if you have to move an object which can roll as well, then it is always easier to move it by rolling. So rolling friction of course must be somewhat lesser than the kinetic friction. From here we can conclude that rolling friction should be less than kinetic friction. Can we write, because you must have also experienced that to start moving a body is relative tougher than continuing its motion. So can we say that static friction should be more than kinetic friction, and this in turn is more than rolling friction? Can we say this? No, this is not correct, because static friction, as I had told you, is self-adjustable. Its value is not always equal to mu Sn. It can have value from 0 to this. So this is not equal to, this is not greater than Fk. Fs is not greater than Fk. Of course we can write Fk is greater than Fr. One other thing we can write that mu Sn is greater than mu Kn is greater than mu Rn. Now this is true because it is the limiting value of static friction, which is always more than kinetic friction, and of course it is more than relative friction. And from here we can write this as well, that 𝜇s is greater than 𝜇k is greater than 𝜇r. So don't be in confusion. Never write that always static friction is more than kinetic friction. Its limiting value is more than kinetic friction. Now two more terminologies are there. One is angle of friction, other is angle of repose. So let's see what these angles are. If it is the body which is in contact with a surface, so what forces will be there between these two contact surfaces? One has to be normal reaction, other has to be friction if the surface is rough, which generally is, because no smooth surface can exist in nature. So a friction has to be there. Now if external force we are considering that is in towards right direction, so of course friction has to be in direction left. This I am writing for the upper body. If we are considering that external force is on the upper body, then lower body will resist its sliding and it will exert a friction force in opposite direction, and this friction force is I have denoted by F. So what are the contact forces here? As you can see, normal as well as friction, both are the contact forces applied by the lower body. If we write the resultant of these two contact forces, this is the resultant force, Fr I am writing for the contact forces, then the angle made by this resultant contact force with the normal is known as angle of friction. This is called angle of friction. Understood this? So what is angle of friction? It is angle between the resultant contact force and the normal. If we want to write its numerical value, then it will come out as tan theta will be equal to friction force upon normal. Now if this friction is either kinetic friction or the limiting value of static friction, then it can be written as mu n. And on dividing by n, we will get this value tan theta to be equal to mu. So theta can be written as tan inverse mu. Do remember this I have derived only if friction is kinetic friction or it is limiting value of static friction. If static friction here is having some different value, then we cannot write tan inverse mu as theta. The other term is angle of repose. Now what is angle of repose? Let's consider an incline for which it is possible to change the angle of inclination, right? So if you start increasing this angle of inclination, let that be alpha. First put some object on this inclined plane and then start increasing its inclination. Then initially the object will not slide, this block will not slide, but when this alpha has reached some value so that it is just about to slide, that value of alpha is called angle of repose. So this alpha is called angle of repose when the object placed on the inclined plane is just about to slide. Now when it will be just about to slide, if you write the forces here for the block, it is mg in downward direction, normal in upward direction, and due to this mg sine alpha component, it will try to come down, so one friction has to be there in this direction. So when it will be just about to slide, we can write that mg sine alpha should be equal to F. Now what is F? If it has the limiting value, because I have said that it is just about to slide, so friction must be having the maximum possible value, that is equal to mu times n. Now if we write equation along perpendicular to incline, that will give you n is equal to mg cos alpha. So here we can write mu mg cos alpha, and mu can be written as tan alpha, or alpha is equal to tan inverse mu. Now if you compare these two results for angle of friction and angle of repose, you can say that numerically these two values are same, but they are not physically equal, because angle of friction will not be always equal to tan inverse mu. As I had said earlier also, this value always has to be equal to tan inverse mu. So they are not same. At limiting condition, these two values are numerically only equal to each other. One illustration I have considered now to explain the concept of friction. A block of mass 8 kg is sliding on a surface inclined at an angle 45 degree with horizontal. Okay, let's first draw this situation on inclined. It has inclination 45 degree. One block is placed here. Its mass is given, that is equal to 8 kg. Theta is given 45 degree here. Now it is asking for acceleration of the block. Friction coefficient is also provided, which is equal to 0.6. Now first you have to check whether it is in a position to slide down or not, because sometimes it will not be in a position to start accelerating if friction is not equal to limiting friction. So first we have to check this value. Let us calculate value of tan theta, that is equal to 1, because angle is given as 45 degree and which we can see is greater than mu. So if tan theta is greater than mu, so body will start moving, and then we have to write acceleration of the body. Now what it will be, if we draw all the forces on this block, the forces are friction, normal and mg. Now if you write equation along the incline, then it will give A is equal to g sin theta minus mu cos theta. That is equal to, on substituting the value, it will come out as 1 by root 2 minus 0.6 upon root 2. And on solving, this will be 2.828 meter per second square. So this is acceleration of the block. One more illustration is here. A block of mass m is placed on a rough inclined plane with coefficient of friction mu and inclination theta. Okay, situation again is the same. This time also it is placed on an incline with inclination theta, and one condition is also given there, that is tan theta is greater than mu. So of course it is in a position to slide. Now we have to calculate range of a horizontal force F. Okay, one horizontal force is applied here to keep the block stationary on the plane. This time the block has to be stationary. If you write FBD for this block, what forces are acting on the block? Mg in vertically downward direction, F is given there in horizontal direction, N has to be here, and then friction. Here we have to calculate the range of friction. So we can consider both the directions of friction possible, because if it has a tendency to move downward, then friction will be in direction up the incline, and if it has tendency to move up the incline, then friction will be down the incline. So we have to consider both the directions of friction to get the entire range. Now for equilibrium of the block, we can write, first I am considering the direction along the incline down, assuming that it has a tendency to move up the incline due to the force F. Then the equation will be F is equal to N sin theta plus F cos theta. This I have written along the horizontal direction, which is our equation number 1. Now along vertical, since it is stationary, so in both direction we can write net acceleration to be 0, net force to be 0. That is N cos theta is equal to mg plus F sin theta. This is our equation number 2. On solving, we will get F is equal to F cos theta minus mg sin theta, this whole divided by sin square theta plus cos square theta, and it is equal to F cos theta minus mg sin theta. Now since static friction can have value from minus mu n, if we consider both the direction, it can be written as mu n is less than equal to static friction, which I had written here by Fs, is less than equal to mu n. So on considering both the extremes, we can write minus mu F sin theta plus mg cos theta is less than equal to F cos theta minus mg sin theta, that is value of friction, is less than equal to mu F sin theta plus mg cos theta. On taking left side of inequality, we got F should be greater than equal to mg sin theta minus mu cos theta upon cos theta plus mu sin theta. And on considering right side of inequality, we got F should be less than equal to mg sin theta plus mu cos theta upon cos theta minus mu sin theta. So the range which we got finally can be written as F has to be in between mg sin theta minus mu cos theta upon cos theta plus mu sin theta and mg sin theta plus mu cos theta upon cos theta minus mu sin theta. This is the range possible for F, so then the block will remain in equilibrium. With this, now we are in a position to solve some basic problems that include friction as well. A block placed on a horizontal surface is being pushed by a force F, making an angle theta with the vertical. Let us first draw the situation. This is the horizontal surface on which block of mass m is placed, and it is a pushing force, so it has to be like this, which is making angle theta with vertical. Now if we draw FBT of this block, what forces has to be there? It has to be mg in vertically downward direction, one normal in vertically upward direction, this F which is at angle theta to vertical, and due to this force the block will have a tendency to move in direction towards left. So a rightward friction has to be there, and this friction has to be equal to mu times n, because already the block has started sliding. Now it is asking what is the force required to slide down the block with uniform velocity. Since velocity is uniform, so acceleration has to be 0. Let's write equation for net force to be 0 in both vertical and horizontal directions. So if we write in horizontal direction, then it will be F sin theta should be equal to mu n. Let this be our equation number 1. Second equation has to be in vertical direction. Now the upward force is only normal and downward force mg plus F cos theta. So this is our equation number 2. If we substitute value of n from equation number 2 to 1, then we can write F sin theta is equal to mu times n. So it has to be mu mg plus mu F cos theta. Let's take F on one side, then F taken common, it can be written sin theta minus mu cos theta upon mu mg, and F we got as mu mg upon sin theta minus mu cos theta. I can remember this question had come in NEET 2-3 years ago. So you have seen now how the questions can be solved if friction is there. Now in the coming session we will do some more questions and we'll learn how all the concepts of laws of motion can be applied in a given numerical. Till then, goodbye.